Once we have the hypotheses, the next step is to design the study. We're going to choose a correct statistical test that depends on what population parameter we're testing, what scenario we have, what information we have, and we'll be learning about each and every one of these that we'll study in our class throughout the rest of the chapters. We'll choose an appropriate level of significance, and this is similar in a way to our confidence levels. The level of significance is actually the alpha. So our confidence level for Chapter 7 in creating confidence intervals was 1 minus alpha, 95%, 99% confidence level. For a hypothesis test, the level of significance is alpha, 0.05, 5%, 1%. So in a way they are related, especially talking about the 3 different methods and using the confidence interval to test a hypothesis, but they are different. One's used to create a confidence interval. The significance level is used for a hypothesis test. And then we create a plan for the study. A statistical test takes the data that we collect, and then we use it to make a decision about the null hypothesis. This is important. When we do a hypothesis test, we always assume the null is true. We're assuming the null is true first, and then we collect the data and make the decision whether we think from the data the null really is true or it's not. If it's not true, we say we reject the null, and if it is true, we fail to reject it. We don't ever say accept the null. We've already assumed the null to be true, so we're not accepting it. We're just not rejecting it. I know it seems like semantics and that they should be similar, but they're very different. They're very differently nuanced when you say accept versus fail to reject. So in the fail to reject, we think the null is true. When we're going through hypothesis tests, there are 4 different possible outcomes. And the 4 different possible outcomes are given in this graphic that has been adapted from Wikipedia. We have a situation of reality. Either the null hypothesis is false or the null hypothesis is true. And we have a situation based on our test. The test leads us to believe the null is not true, or the test leads us to believe that the null is true. Because we have reality, 2 outcomes, and we have the possibilities on the test, 2 outcomes, we ultimately have 4 different situations that we need to address. If we think the null is not true, and it actually is not true, we have a correct conclusion on our null hypothesis. So this is a good thing. Notice that check mark there. This is good. Correct rejection of the null. If we think the null is true, and in reality it is true, this is another correct conclusion. The goal is that we land in one of those 2 scenarios. But there could be the case that we reject the null. We think the null is not true when it actually is true. And we call this a type 1 error. The type 1 error probability, or the probability of a type 1 error, is given by alpha. A type 1 error occurs if we reject the null hypothesis when it actually is true. If we think the null is true, but in fact it's really false, we have something called a type 2 error. A type 2 error occurs if we do not reject the null when it is indeed false. We're going to look at a scenario where 2 people are taking a pregnancy test. The null hypothesis for a medical test is that you don't have whatever condition that they are testing you for. Okay? So the null hypothesis is you're not pregnant. This goes for any medical test that you're taking. Let's take a look at a pregnancy test. So we have 2 pictures, and yes, this is meant to be a little humorous, hopefully to remember the difference between a type 1 and a type 2 error. You may have heard of false positives and false negatives. A false positive, or a type 1 error, occurs when you reject the null, but the null is actually true. So notice our null up here up top, not pregnant, but we reject the null even though the null is true. Like case in point, the doctor telling the gentleman, you're pregnant. That's not going to happen. Looking at the type 2 error, this is called a false negative. And a false negative occurs when we do not reject the null, when the null is false. So it's a false negative. So here we have a doctor telling what looks to be a pregnant woman, you're not pregnant. So we did not reject the null of no pregnancy, but that null is in actuality false. This is the difference between a false positive and a false negative. One of them, we're rejecting the null, but the null is actually true. That's a false positive. In a false negative, you're not rejecting the null when the null is actually false. Each one of these has different implications depending on the test and the scenario. One thing that we can directly control is the probability of a type 1 error. The probability of a type 1 error happening is given by the symbol alpha. For a false negative, the probability of a type 2 is given by beta. Alpha is really easy to control. That's actually our significance level. We can adjust our significance level to whatever we want it to be, and we can control the probability for our type 1 error. Unfortunately, for a type 2 error, beta is hard to calculate and not as easily controllable. It does turn out that alpha and beta are directly related to each other in the sense that if we increase alpha, we decrease beta. And if we decrease alpha, we increase beta. So we have a very fine balance between the two probabilities in the testing. Now, I say all this not because you're going to be doing a lot with these probabilities. The big thing you're going to be doing is picking alpha for your hypothesis tests. But just to be aware that for type 1 and type 2 errors, we cannot make them all go away. We'll never be 100% confident in our results. And this is what makes statistics very different from mathematics. We have this level of uncertainty that we have to be okay with. And that if we run a test with a completely different sample, we can get a completely different conclusion. Repetition is often used to verify results, but sometimes that repetition doesn't verify them, and so more tests are run and more tests are run. There's a lot of verification going on in data science because of this uncertainty. So we talked a little bit about this before. The significance level is the maximum probability of committing a type 1 error. We symbolize this probability by alpha. So type 1 error probability is given by alpha. Similarly, we denote the probability of a type 2 error as beta. The power of a test measures the sensitivity of the test to detect a real difference in parameters if one actually exists. The higher the power, the more sensitive the test. So here the power is 1 minus beta. Alpha and beta are related in that increasing one decreases the other, and we mentioned that before. And beta is pretty tough to calculate, so we tend not to do that at this level in our statistical learning. Let's take a look at type 1 and type 2 errors. We have a hypothesis test. There's a claim. The medical test indicates the patient has diabetes. A null hypothesis would be the patient doesn't have diabetes. We always assume for a medical test that they don't have what we're testing for, and then we use the test to show otherwise. It's very similar to our null hypothesis. We assume there's no difference in the mean and some value, or the proportion and some value. And then the alternative is there is a difference. So these are our null and our alternative hypotheses. But if we're talking about a type 1 error, a type 1 error would be a false positive. We reject the null when it is indeed true. So a type 1 error would be the test indicates diabetes when the patient actually does not have it. And a type 2 error would be the test does not indicate diabetes when the patient actually does have diabetes. In the next part of our lesson, we'll break down more about the hypothesis test and try to put all of the pieces together, start to finish, and then in future lessons, we'll put it into practice.